Yeah. So I guess we can start. Um, since Dano could not make it, I'm going to propose that we start with Ansgar. He wanted to give some thoughts on the EL roadmap, like especially focusing on Amsterdam, and then we can have a discussion from there. And then there were a few minor things that people wanted to talk about. I know Jacek may have a small update on his repricing. I also thought maybe it's worth to have a small discussion on the exponential gas limit increase proposal from Dankrad. So I think we can have those later as well. So today it was more discussion form, less presentation.
Yeah, hey, I mean, I really just very basically briefly. I also don't really have a presentation. I can maybe one sec if I share my screen. I can just briefly. So we had the research call a few weeks ago where we talked mostly about other topics, but I already gave a bit of a sneak peek of the second research call, which will be next week actually, and probably be quite interesting to attend for people here. Um, and just as like a categorization of basically like this specific topic of kind of execution, throughput, scaling, how that intersects with the roadmap. And I just wanted to talk about like for 5 minutes right now, just to set a little bit of the scene of like because obviously the upcoming Amsterdam Hack for hard fork will be the first fork where a lot of this repressing work and the other kind of work streams will actually be able to go into the protocol. And so basically, that's kind of the short-term execution layer box. And so within that, that was just the one slide. And this is really the only slide I have. Basically, that's just the slide from that call from a couple of weeks ago. Just to give you a rough idea of basically so basically, I think that what the way Amsterdam will shape up is that on the EL side, basically we will have some subset of these features and maybe one or two of the features that are not listed here, but basically just features that help enable higher execution throughput. And then on the CL side, we'll continue to do some more PIDAS improvements, and that will basically be it. Um, and so in particular, right, like the most important candidates there to have in mind will be delayed execution, I think, and well, block level access list and parallelization, which more looks like it might just be one combined feature because if we actually do access lists kind of on a per transaction level, then you can basically run transactions in parallel, which is quite nice. So those are basically like the main kind of headliner um, features that are being prepared for Glamsterdam. Um, outside of kind of narrow pricing. Um, Now basically, one big kind of deviation from how we've done this, of course, in the past, and a lot of people on the call here are already more on the engineering side anyway, and so basically probably that's not news for you, but obviously now I think with these upcoming kind of scaling changes, it's a lot less kind of going through just the instrument of new features in hard forks and a lot more about just like performance engineering. So even before Amsterdam, obviously now we're running these performance devnets or starting to prepare to run them. So I think a lot of kind of like work on scaling will also just be about taking the existing protocol and just run it at a faster pace with the gas limit as is. And so basically, I think you should really think of it as these two pillars. So there's like the new features, but then there's also just like take this existing thing and just make it run faster. Um, and so then the basically the goal of the repr of pricing to me basically is to like to support both of these buckets. And so on the feature side, like there's also just like separate features. So for example, the repricing we've talked in the past is mostly about increasing compute throughput, right? So basically just like harmonizing how compute is priced. So right now, basically some things are too expensive, some things are too cheap. Just metering them in real conditions and basically just repricing things relative to each other. That just means that you can have somewhat higher compute throughput overall because you basically your worst cases get better, right? So that's in a way a scaling feature in itself that just makes compute scaling like this scales compute scaling by some percent. Um, there is but I think it's important that we basically like now that we are kind of working on repricing, we are also preparing to support the overall kind of like general scaling more. And in particular, what I would say is if we expect the chain in a year to run at maybe 5 times the speed that it runs today, um, then the question becomes like basically we will hit specific bottlenecks and like repricing will be one important tool in the toolbox to just like in the short term deal with bottlenecks, right? So basically the way you deal with bottlenecks is you basically short term just contain them and then long term you remove them, right? Containing them can be very simple fixes. So for example, with the size of blocks, that's one immediate limit that we are running into right now with the early devnets. And so they are like very simple fixes, even simpler than repricing, just like for example a cap on maximum block size, right? There are some questions on the pricing side that we should look into, meaning like how low can you have the cap relative to the maximum that a block could have size before the fee market starts to break down, right? And like basically like how carefully should you be with a pragmatic fix like that? So that is a fee market question there. Um, but of course, you also like you can't limit every dimension in a simplest way as that. Sometimes what you instead need to do is you need to just like make pragmatic short-term pricing changes of different dimensions relative to each other. So it might be that we are like okay, that we are realizing, hey, state access is the main bottleneck right now, and everything else we could push farther, but because of state access in the worst case block, we can't push farther. You probably can't really introduce a cap of maximum state locations touched in a block or something. That would be a very blunt mechanism. What you want to do instead would be to just like say double the cost of all of the state accesses, leave everything else the same. Of course, make everything else cheaper, whatever, like same outcome, and then keep pushing the gas limit, right? So basically, like the repricing there would have this role of short term just getting rid of the bottleneck, so that you can keep pushing there. And then in the medium term, of course, we look into how can we overall just make state access more efficient, both in terms of implementation, but also in terms of protocol changes, right? So basically, it's always this interplay of short term, just contain the problem, so we can push in the other dimensions, and then address it, and basically then once it's addressed, make it cheaper again, and these kind of things. So that's what I assume the interplay will be in the future between pricing um, and these other scaling features. And then the one important aspect there, and that's why like it's important, I think, that we talk a little bit about Glamsterdam or just this general fork scheduling, is just that we have this mismatch, unfortunately, where a lot of even simple relative pricing changes, if we want to make state accesses double, like twice as expensive compared to everything else because it's the bottleneck, just as an example, right? That has like almost a year of lead time, maybe 6 months if we get lucky with a hard fork timing. But that's a very different lead time from a performance DevNet, right? So basically, like anytime we run into this, ideally we would want to understand what the bottlenecks are as early in the process as possible, so we can make sure we address it. So for example, I think one big question for the repricing effort today, I think, should be how can we say we have another 2 months or so, 2, 3 months to make decisions on what features go into Amsterdam. How can we, within those 3 months, understand what dimensions currently are the main bottlenecks for scaling? And how can we basically like have repricing changes in Amsterdam if we figure out that we need them that can unblock us there, right? And so how can we basically like play this game of being of relatively early on understanding what bottlenecks to get to like preemptively get rid of. And there's not that much of a cost to getting it wrong. If we make something more expensive and it turns out we actually found other ways to addressing it, or it's not the bottleneck after all, that's fine. Then for a while it's just a bit too expensive on mainnet. If we get it wrong the other way around though, we're just hard stuck, right? So if in Amsterdam say we fail to make a specific dimension more expensive, and that's just the main bottleneck, and we don't have any fix for it, we basically have to wait for the next hard fork until we can keep scaling the L1, right? So I think that's I would basically just that's kind of the only message that I wanted in my section. Basically, it's just that like repricing is not just a self-contained topic where we can play with like multidimensional gas and these ideas and maybe like this compute repricing. I think we should also prepare to like have the pricing work be very actively supportive of the overall scaling efforts. That's kind of the only thing. Sorry, I didn't have specific slides for this, but yeah.
I think this is great.
Do we want to like briefly, I mean, given that we don't really have any presentations today, more like discussion, do we want
Yeah,
to have like a discussion on this specifically before we move on, or?
yeah. Maybe I can start with one question in my mind. Like, since essentially now like this role of like repricing is kind of like becoming potentially more dynamic, right? We want to use it as a tool to like help with like potentially like performance bottlenecks, etc. Like one thing that I was discussing with Dan offline was this idea about like having some sort of like standard config for like gas costs that is kind of standard across multiple clients. Like, is this something that kind of could help given like the scenario you're sharing where like potentially like these updates to costs are much more frequent and also maybe with shorter lead time?
Yeah, so basically, I think that's like a really, really good question. I don't know. I would defer to EL clients, and if we have any on the call, maybe that would be a good question actually. I do think preparing for a world where we might want to change this more frequently, and we're basically changing the gas cost is a relatively like is a very, very low effort thing to do in a hard fork, and even to do it relatively late into the hard fork planning cycle. I think that would be very valuable. If there's a way we could go get to a world where we could even do it in between hard forks, where it's some sort of on-chain parameter or something, that's probably unrealistic. But anyway, like I would be curious about how EL clients think about making it easier to change pricing in the future.
So the on the Reth side, not exactly changing the actual costs, but right now the Reth team is working on some RPC methods for basically being able to provide um, a list of costs per opcode, and then it reperforming traces that give you data on how much things would have costed in a block or in a transaction. So if we are thinking about new price schedules, this could be a source of good data for figuring out, okay, what would the effect of this price change actually have been in historical blocks?
And this is a naive question, but would I be right in assuming that that work also would make it then easier to change pricing in general because you already have code paths that deal with dynamically different prices or something?
I think I think that's a lot harder because the way that the RPC methods are designed, they have like very segmented code base that's like for tracing, and they can just add a bunch of stuff easily into the tracer. And they've been sort of developing that capability. And my understanding is that's a pretty separate code path than the actual use prices, but I'm not sure.
Okay, that's good context. So basically the main value there, what we're saying is would be in us being getting quicker at understanding what the impact would be of different prices.
Yeah, so let's say we come up with like five different ideas for possible price schedules. We could, you know, maybe within like less than a day get like a feedback loop of what the effect would have been with historical blocks.
I see. That makes sense. This is actually an interesting question. How does it intersect with like, say, if we run like a performance devnet and we realize that, I don't know, we really struggle to move beyond 100 million gas or something. And then it turns out, okay, but it's really just because we run all the different worst cases, some blocks that are really heavy on compute, some blocks that are really heavy on state access. And every time these really heavy state access blocks, they just slow the network down so much, we just can't go to 150 million. Um, how do we get like what would it mean to get data on, say, if we make state access more expensive? What kind of data would we want to inform us on whether that would have successfully resolved the problem?
Well, I mean, if we use like real historical blocks, that's probably less about the worst case and more about the expected case or the mean case. And then if we do it on these performance test nets, then that could inform the worst case. And then I think the place it would be most revealing is if there's maybe like a non-obvious um, it's not exactly obvious like which opcodes or like the exact distribution of opcodes were used, and it's really expensive to trace every individual opcode. So we can just easily swap out a different pricing schedule and be like, okay, well, if we tweaked this, then would this worst case be toned down significantly without affecting the other cases that we care about.
Makes sense. And then that is then I guess still a separate question, but if say we alternatively would want to just as quickly as possible just spin up an entire new DevNet that just uses a different pricing schedule, you're saying basically that would be more complicated because that's just separate, completely separate from these tracing code paths and also just overall a more involved change.
Yeah, I don't know. I don't know exactly, but I think like somebody mentioned creating a standard config for that. That sounds like a really good idea.
Yeah, I think at least again, I think it's unfortunately this is really more of an engineering question. I feel out of my depth, but it feels like having a standard config would be very useful, and I could imagine that also separate from the L1 use cases, I think also L2s would be very happy about basically that way it being easier for them to just run different pricing schedules.
Cool. Yeah, I can push the conversation forward on this since we were already discussing with Dano as well. Yeah, maybe like related to like the other thing you were saying, Ansgar, like about like the repricing effort for Glamsterdam, right? Yeah, one thing I was thinking is so we have this proposal from Jacek, right? But this is like essentially like this very broad repricing, right? Looking at like most opcodes. But you were starting to talk about, maybe like we can have an effort where like within the next 2-3 months, as we finalize changes for Amsterdam, we try to like identify priorities. Like maybe also one question for the group is like, how do people feel about like the repricing proposal as is, like versus like prioritizing specific maybe a subset of opcodes. Maybe Jacek, if you want to talk to this, I'm sure you got kind of feedback and discussions on this already.
Yeah, let me just quickly remind what the proposal is, if I can share my screen. Yeah, can you see it?
Yeah.
Okay, great. So the general pricing proposal looks at all the opcodes, all the precompiles, and say, why don't we start from scratch and base the gas cost on some evidence rather than analysis of what the opcode could be. And by having such a motivation to do it, we came up with a number of research, and then with this proposal, which simply says, for most of the simple opcodes, we want to change the price to the base cost, which is 1. And then for anything which is more complicated, computationally complicated, then we adequately increase that cost. This proposal also simplifies some memory cost formula. It makes the warm addresses cost cheaper, and so on. So in essence, the idea is very simple. So we just replace everything starting from 1. The effect on the network is moderately analyzed, and we know more or less what we can expect. The effect of the EL teams, how to implement it, might be more complicated. As we said before, we don't really know how easy it is for the client teams to have a new gas cost schedule. Okay, so that's reminder of what it is. From some updates on this front, we are doing some what-if analysis. So basically to show how this change will affect most popular transactions, so swaps, transfers, and so on. And few other analysis of that sort. When it's ready, unfortunately, we're not ready yet, but when it's ready, we will show you. Though, two questions were raised about the actual gas cost proposal. So in this proposal, we aim to radically make easy pairing cheaper. Now, Julie B has raised quite rightly an issue that most of the implementations are very well written, performant, and this reflects what most implementations are actually spending time on. But two implementations, namely Geth and Eragon, which use the same easy pairing implementations, are definitely standing out. So, and they are much worse than the rest of clients. So around 5 times worse. And the question that we have, do we aim at the worst case scenario or at the typical scenarios? I summarize it in here. Maybe I make it slightly bigger. But if we have such a discrepancy between client, we can go with the worst case scenario. So basically base the gas cost on the slowest implementation, somewhere in between. So use either average or median, or in the best case scenarios. All of those approaches have some pros and cons. We usually tend to go with the median, which gave us the best results. But in case of easy pairing, the difference between a median and the two worst clients, Geth and Eragon, is so big that it might, in some effects, affect network security. So at the moment, we are revising this precompile. Also, Piotr Dobaczewski from Epsilon team has raised a good question. I'm not sure how deep you want to go into this, but he raised a question. Are we sure that we always take the most expensive scenario when it comes to some simple arithmetic opcodes? And to show you the actual problem and differences between clients, I can show you this nice graphs here. And what we see here is the diff opcode execution time in dependence of the size of arguments. So diff takes 2 arguments, and we can see by increasing, this is a case of Eragon, by increasing size of first argument, as expected, the execution time goes slightly up, but not that much up. It's starts from 4 and ends on 5.2. So difference is not that big. The size of second argument doesn't matter that much. So this is Eragon implementation. When we move to Nethermind, we see that diff is almost linear because the difference between best and worst case is not that big. But then we move to Geth, and the same opcode gives you very different results. And we can see that Geth implementation have somehow like 2 paths depending on the actual value. So you can either go into the fast path, which is about 5 milliseconds, or you can end up with a slow path, which is 11 milliseconds. Difference is big, and this might cause some underpricing depending on which value we used as a outcome of our analysis. Sorry for being that technically deep on this one, but it just to show that there are some subtle things that we still need to consider. I don't expect huge changes in arithmetic opcodes, but as it goes for the easy pairing, we probably need to seriously revise our gas price and go with network security rather than average cost. Okay, that's it. Do we have any questions on this?
Thanks for the overview, Jacek. Yeah, I think there is some interesting questions in the chat, if you can see it.
A good question. Measuring M gas is always difficult because I'm looking at the first question from Dan. Measuring gas from M gas, it's always difficult because it obviously depends on your PC that you measure it on your machine. But from what I remember, the slowest and the worst case for the easy pairing after the repricing on Geth, it was about 40 million gas per second, which is too low for the network security. And the fast clients are like 150, 200 million. Yeah, what inputs we used for easy pairing or other precompiles? It's all the inputs that we found from the actual testing, EIPs and so on, which give us the worst, typical and best scenarios. And usually we use the worst case scenarios. I think we always use the worst case scenarios. Okay, what next?
Yeah, sorry, I put some comments in chat. That wasn't really questions. A bit long.
Yeah,
but,
exactly. I'm just looking for the comments.
Yeah, I was just curious. Maybe the rounding one is the most pragmatic one. Like with these benchmarks, I saw because when I looked at the kind of underlying results, it was usually like just rounded. So like 1.3 kind of gas was then just rounded down to 1. And I'm just wondering, like my feeling is we kind of need to always round up. Basically, so if something basically if the true price of something should be 1.3, then we should price it at 2, not at 1, just because otherwise basically that one becomes too cheap, and then basically it just drags down the worst case kind of gas per seconds that we get to for everything then.
It's actually a very good idea. We went with the standard rounding just because, but rather than doing that, we always go to the ceiling. It's not a bad idea. We can run some analysis and see what the effect it will take, how many of these opcodes will go up. I guess this more complicated will actually change from base 1 to 2. But yeah, I can prepare a scenario like this and show it here.
Yeah, that would be. And of course, I mean, hopefully not much changes, because if a lot changes, then we need to think about whether we really want to do that. But yeah.
Yeah. Let's see the actual changes. I would prepare a comparison chart and then we can discuss.
I mean, also dependent on having the actual changes, but it might be worth like setting a rounding threshold of like 1.3 or 1.2? Like, I think if something's the real cost is 1.1, then rounding up seems a bit insane.
I had this chart somewhere. I don't remember well exactly, but yeah, I will post a link when I find it
Okay, thanks.
with the actual values. Storm is saying that it would be helpful to have a table that just MGAS for each opcode. Yeah, I wanted to avoid it just because it's always refers to your actual machine that you run the MGAS on. But I think we are in position to have for the reference such an calculation, MGAS calculation. It would be very good actually. So I will add it to the proposal as well.
I'd be curious if you like you already talked about it a bit. What do you have any further thoughts on this question of how to deal with the fact that different clients have different behavior? I feel like in the past we were always so far away from the bottlenecks or like the efficient frontier that it didn't matter. As we try to really push, how do we should we focus on harmonizing client behavior? Should we like I don't know, how do you have any further thoughts on this topic?
So I think we have to make a distinction here. For the most of the opcodes, the implementations are slightly different, but they are so close together that it actually doesn't matter. Even if some opcodes it's underpriced or overpriced, it is by such a small factor that it really doesn't matter. The problem comes when we have a thing like easy pairing, and we have really big differences, and it might open even some vector of attack on the network, just because in the worst case, mgas mgas per second will be less than the block size, which obviously it's not what we want. How to deal with that? We have three options, really. Going back to this worst case, best case average. If we go with the worst case scenario, so we price it accordingly to the slowest implementation, then we have the network security. What we don't have is some kind of incentive to improve implementations. If we go with the best case scenario and we price it on the fastest implementation, of course, we somehow punish the slowest clients, but obviously at the risk of network stability. Average or medium approach goes somewhere in the middle. How to do it, deal with that in the future? I don't know. It's probably case by case scenario which we have to review and decide what to do about it. So in the case of easy pairing, I'm aligning with the worst case scenario now, just because the potential vector of attack might be too probable.
Yeah, thanks. That's I feel like this will probably come up in many places, right? Like now we're looking at it for opcodes and for or precompiles, I guess in this case. But I mean, you could imagine the same thing with anything, right? Like different database layouts that lead to like one client having much worse performance on some specific kind of aspect, or different sync behavior, or different like we will run into this like once we start pushing, and basically all of these different areas of client performance will start to hit the limits. There will always be one client, like hopefully in many areas all clients will have similar kind of performance, but there will always be the one client that is just worse than everyone else at a specific thing. And so the question is, how do we in general approach this? So I feel like we shouldn't have like a pricing specific strategy for this. We should just overall figure this out.
Overall, we use the median approach, and which I think worked for almost all of the cases that we had. Easy pairing is more an exception, and we need to look closer to it.
Yeah, it's a good question that Storm has in chat. Like, because I mean, just because again, like we'll run through this all the time. So I think treating the kind of this specific case is just like a little bit of an example of how to deal with these things. So like, okay, we have clients that are slower than everyone else. Like, what are these clients doing to address this?
It's a very good question. Yeah. So, and also that brings the question: are we proactive or reactive? Do we just want to measure and go with that, or do we want to be more proactive and somehow force clients to improve the implementation and optimize things?
I think like
Yeah.
so far there hasn't really been good data on the per client performance, especially not at the opcode level. And merely just publishing a table of how fast each client is for each opcode would do a huge amount of just awareness for pointing out where the bottleneck is for each client. And that could create a really good feedback loop for pointing clients where to go, for sort of like the community gathering awareness of where these bottlenecks are and acting appropriately.
It's very tempting. Of course, all of this data is available, and but we wanted to avoid direct client comparison, not because we want to hide this data, but we wanted to avoid some unnecessary battles between clients saying my client is better than your client and so on. It's completely pointless. But in this case, I do agree that it will actually help with raising the awareness of different implementations. And in our report that we published earlier, we highlighted some issues with specific opcodes in specific clients. And we know that some clients have already acted on it. And I can show you an example of what we actually said. So in here, when we have some kind of summary, I left a client implement, or maybe I make it slightly bigger. I made some client implementation notes, for example, saying that Besu and Ethereum, Ethereum.js have some push issues, push implementation issues, and things like this. And some clients have already acted on this data, and then they improve it. So yeah, sometimes comparing clients is actually helpful. So I guess more work for me to create such a comparison for each opcode and precompile.
Yeah, and I agree with Storm that, like, I think we all on the same team here. So like I mean, obviously it's on us to set the constructive atmosphere and like actually be mature about this. But I think in principle, being like, hey, look, this client has some issues here. Let's just together help them figure out what is the issue. Maybe it's like sometimes these things are hard to address, right? Like if it's a precompile and the library in that language for some reason is less efficient and it's really hard to fix, like, maybe we have to accept that bottleneck will exist for a while. Like it's not doesn't mean they are doing a bad job or anything. So I think I do think transparency is just super valuable on this.
I agree. Just in the beginning, we thought that we don't really want to point fingers. It's very easy, and as you said, there are lots of factors that are actually driving specific performance. Yeah, and it's very easy to judge just based on the outcome of it.
Yeah, I agree. I do think, by the way, because like I really feel like the repricing here, we are in a way like this topic is ahead of most of the other topics. And I think so it's a really good example. Like here we can practice building these feedback loops, making sure that this data doesn't just exist and then no one looks at it, but that there's a feedback loop where that now goes to the clients work on improving their worst cases and so on, right? So like, because I think what we will have to then also do soon, and so for this is super valuable, is to look how to generalize this type of approach, right? Like I would love for someone to do the same work on sync performance, right? Like figuring out, okay, how does that is that impacted instead of here by different opcodes, how is it impacted by the rate of state change, right? Or the state size, or whatever, all the factors that impact that, and then also understanding, okay, this of course sync would be a topic where there would be a lot of difference in client behavior, or say like I don't know state accesses, all these kind of different ways. I think we need to have the same approach, metrics of different client performance, understanding where the differences come from, address them, price for the worst case, but like at the same time help them improve the worst case. I really feel like we need to get that flywheel going basically everywhere.
Mm.
Maybe this would be a good topic, kind of like in the later in the year when we have the interop meeting. I guess we try to not have too much talk about the details of these events kind of on public calls, but like like once there's another one upcoming, that could be a good topic, like a good area to make progress on.
Okay, so maybe closing on this general pricing, I we'll try to finish the what if scenario, showing how these changes would affect typical transactions, add some MGAS analysis, and maybe client comparisons.
Sounds good. And Davide, you asked when you introed the question. Oh, sorry, Sophia, do you want to say something?
Yeah, I was just going to make a suggestion, Ansgar, based on something you said in the chat, that it may make sense to separate it into one EIP for, I think, the opcodes and then one for the precompiles. My hope for this is that it's really non-controversial, and I think that for all the opcode pricing, it looks like that to me, meaning doesn't differ greatly between clients and is largely unlikely to change in the future. For example, it doesn't intersect with ZK-related repricing. So the precompiles seem to me to be outliers in that sense. I'm not sure how these ones in particular, how ZK proving works with them, but I think that that it's possible that's a factor, for example.
Yeah, I mean, I think ZK is just in general a big topic. We have to kind of figure out how we think about this.
I am not I'm not super hopeful that we'll have benchmarking for that in time for Glamsterdam, though I think that that's something I hope to discuss in Berlin interop. But I think that it is clear which opcodes are likely to be affected, right, by proving, right, rather than just the interpreter cost dominating proving costs. And so I think, for example, the compute ones here are, I can't see why those would be affected at all.
I guess there's more question on my side is related to the first thing that Sophia and Ansgar mentioned, which is like Jacek, whether you've considered splitting it, into like a few categories of opcodes, like a few EIPs. Yeah, because it seems like it's a really well thought EIP and exercise, and there is general agreement that we should do it, but it seems you didn't get too much like feedback even in the forum, etc. I wonder if like people are a bit overwhelmed with this slash, as you were saying, like we don't have a super streamlined way to change like we don't have the standard config yet, so yeah, people may be a little bit I don't know if scared off is the right term, but like colder to engage with this since it's so big.
It's not a bad idea. So usually we say smaller is better because a smaller chunk of work is easier to consume by anyone. There's one issue I see with this. All of these changes come from the same research, and they are part of the same proposal, repricing proposal. Now, if we say, let's say, split it into 5 EIPs and only implement 3 of them, for whatever reason, the remaining 2 groups of opcodes or precompiles are not in sync with the rest. So what we really gain from splitting into multiple EIPs? Just more chaos, really.
Yeah, I guess one way to look at it is that the compute opcodes is like basically the relative cost between them is also important, right? But I think the way Ansgar was putting it, which is also how I think about it, is like, okay, if you can separate like some group of opcodes that are kind of orthogonal to like compute, right? I don't know if state access is a good example, but then essentially maybe it's okay that there is those changes that go later, like if the relative costs are not that important.
Maybe you are right. I'm not sure really. I'm happy with both approaches. It just I'm worried whether it's going to be implemented at all if we start splitting it. Or maybe it is easier. I'm not sure. What do you guys think?
It feels like we should, that's the kind of decision we can only make once. Like once we split it, it's weird to like re merge it together or split it a different way. So maybe we don't split it for now because I do get your points that like if it comes from the same methodology, like yeah, it kind of belongs together.
I think the only reason to split it is if we're likely to have great debate about some parts of it and not others. So that's for example why I mentioned precompiles, because it potentially has an issue with different significantly different implementations, and because we're making them cheaper if they are more expensive to prove, or we have an idea they might be more expensive to prove, then it might be a better idea to just leave them at the current cost until we have proving benchmarks. So that's why I suggest that. Generally, I think that consolidation is better.
But that's okay. Quick general philosophical or like kind of approach question. Like I feel like we should just normalize pricing changes and frequent pricing changes and build out the infrastructure so that it becomes almost trivial to just feed in a new kind of file with different prices every hard fork, because then it wouldn't be a big deal, right? Like we just make it cheaper in Amsterdam, and then by the time we want ZK EVMs, we're like, interesting. Actually, this specific precompiler is a bottleneck. We want this to be more expensive again. And then it was cheaper for 6 months, and then 6 months later it becomes 3 times as expensive. And to me, that's fine. Of course, yeah, if it basically feels like we only make these changes once every 5 years, then it's much more pressure to get them right.
I think there's a couple of things about that. So one, I think that to the extent that we can predict, it is better for the changes to only be monotonic, right? So the things I see that potentially not being that case for are, for example, like potentially these precompiles or hash functions, right? That might be cheaper to traditionally compute and more expensive to prove. I also just kind of like disagree that we're likely to want to change most of these things in the future. I think that most of what's in this proposal, I honestly don't expect we would like ever change again. The ZK stuff, yeah, it's possible that the implementations change, and so we change those multiple times. But most of this, I don't think, even the memory ones, I think the only thing that's been discussed is potentially we make like fresh writes more expensive. Those, of course, they don't significantly change in this. So yeah, I mean that's the other thing is I sort of differ in the opinion that we're likely to be changing these that many times in the future, and for most of them.
It just feels like sometimes.
Sorry, I was just responding to what Storm said in the chat. I'm just sort of assuming from a DevX standpoint that developers have like intuition about developers or compiler engineers or language engineers, I guess, have an intuition about cost that better not to break extremely. Not that they're dependent on the specific gas cost, but that seesawing could be bad.
I think I disagree with this. Yeah, or rather, yeah, I'm with Storm in the sense that like it seems like a nice to have where like maybe in the long term we should probably try to focus more on this. I think right now we're coming out of this phase of like being barely ever daring to touch anything about the system, and I feel like that's been holding us back in the past. So I think it would actually be beneficial for a while to just be willing to just make changes and see their effects, and then over time like try to become a bit more predictable again. And it's not like the minutia of, oh, okay, this opcode is now 3 gas instead of 2 gas. It yes, I understand there are gas golf contracts on mainnet, but maybe that is okay. Maybe this is the cost we have to pay here. Like basically, if we want to start being innovative here, we have to just be okay with gas golfing being no longer permanently optimal on mainnet.
Yeah, I agree with that in principle, and I agree with Storm that should be a hard requirement. But I think that like we should be able to look forward at what would likely change and based our plans now on that. And that if we don't have any reason to think that something would likely change, like say the cost of the compute opcodes, I really just can't imagine. Then I don't know, we could base decisions on that. And what I project forward in this, I think the majority of it is unlikely to change.
Yeah, well, we're running up at the end of the hour anyway, but like, yeah, like the one last thing that I would say there is maybe we should approach a different way and just start getting better at giving much more explicit guidance. Like if we ship a feature and we like a hard fork and we make a precompile cheaper, it should be very clear for developers and compiler people and everyone, like there should be a clear resource where we say, look, this one we basically make cheaper now, but we are still like there's still ZK benchmarks pending. This could become much more expensive again in the future. You basically make sure to not overly rely on that specific price or something.
There's also probably a point to be made that if I'm mainly making this argument about the precompiles, I imagine what I'm saying about DevX is probably a lot less true for them than the opcodes, right? So, given that they're relatively expensive anyway.
Makes sense. Okay, yeah. Then I think kind of coming out of this specific ERP discussion, I would just say like again from kind of tying it back into what I said at the very beginning of the call, I think the way I would think about this, that the goal of like ERP 7904 is basically to just overall make compute more efficient. So basically make it so that everything that just takes some milliseconds on a node to run now is harmonized, that it all kind of costs the same amount of gas per millisecond or so that it takes. Kind of that's at least the intuition. And so we can overall kind of crank up gas more and be more happy that the worst cases are not so bad. And that we should in our head clearly distinguish this from the second category of repricing that I think we haven't really done much in the past, only once or twice about state, but we will probably do much more, which will be just like, okay, look, right now the scaling bottleneck is this category, so let's just make this entire category more expensive so that we can overall crank up the gas and not be held back by this one specific category. And I think we should separately prepare for a world where ideally we would want to do this every single hard fork, and we probably ideally would want to wait until as late in the process as possible so that just having the general infrastructure built out that we can swap in a specific kind of like config file and that just works seamlessly and is low effort for people. I think that would be like really, really valuable to help as a supportive thing for overall kind of scaling of it. But yeah, I hope this wasn't too much. I always have a bad feeling when I leave a call and I talk too much, but I think that was a good call.
I think it was productive. Yeah, we have a few things to follow up, and then there is a few topics we can pick up in the next call. Yeah. So thanks everyone for participating.
Thanks, Davide,
Thank you.
Thanks.
leading these.
Thanks,
Right.
Cole.